Okay.
Yep, looks good.
Okay. Hello, everyone. I'm Yifei Li from Southern University of Science and Technology. Today's topic is UniFaaS, programming across distributed cyberinfrastructure with federated function serving. I believe that it is very exciting for our community to execute the scientific workflow across distributed cyber infrastructures. There are many benefits to doing so. For example, we can utilize multiple supercomputers to amortize the queuing time, or we can select the near computing resource based on the data distribution. Furthermore, we can put some training task on the specialized accelerators cluster. So if we want to execute a distributed scientific workflow by current frameworks, here are some problems. We can easily build a distributed computing resource by Funcast, but we know that the execution is independent and the users should do data staging manually. There are also some limitations about input and output size. So what about Parcel? We know that Parcel supports the DAG workflow and it can also do data staging by FTP, HTTP, and other protocols. But sadly, it is very complicated to execute workflows on the distributed resources. So it's natural to introduce Funcast as an executor of a parcel. If we combine parcel and Funcast in this way, here are things can be resolved immediately. Like, for example, users can easily program in parcel's way and send the task to the remote endpoint by Funcast. But there are other things to be resolved, like how to do data management automatically and how to do scheduling for the execution performance. So we present UniFaaS, a framework combining Parcel and Funcast, and try to address these challenges. This figure on the left shows how to write a UniFaaS task. We implemented a shim layer to wrap the data, so users can conveniently perform file read and write operations. And other things like the decorator and the future object and so on are really similar to Parcel. User can write the workflow in a similar manner as they do when using Parcel. The core components of UniFaaS include scheduler, monitors, profilers, and a local store. The monitor can collect the status of remote endpoints and the information about executed task by polling the Funcast web service. The profilers will build some models to predict the execution time and the transfer time based on the historical information. The data transfer between endpoints can be performed using either global transfer or rsync. So let's focus on the scheduling mechanism on UniFaaS. Our goal is to minimize the workflow's mix span, and there are two major challenges. The first one is the data staging time may vary from seconds to minutes, and the second one is the capacity of endpoint may also change. It is very easy to understand because the batch scheduler will not always provide the resources in time. Here are two intuitions respectively. For the data staging problem, we should start data staging as early as possible to overlap data staging and the execution to reduce the mix span. And for the dynamic resource capacity problem, we can make scheduling decisions based on the real-time status, which is called real-time scheduling. But you may notice that there is a contradiction. If we want to start the data staging as early as possible, which means making decisions earlier, but it is contradicted to the real-time scheduling. Real-time scheduling means later decision. So to solve this problem, we propose a dynamic heterogeneity aware scheduling mechanism. I will call it DHA in short later. DHA will do scheduling for the task whose all dependencies are ready. And then it will select the best endpoint that minimizes the completion time of this task. In the data staging queue, the pending task will not be dispatched immediately if the corresponding endpoint is busy. Otherwise, DHA will periodically recompute the scheduling decisions and perform a task stealing if necessary. So in summary, DHA will do the first-time scheduling when dependencies are ready in order to start the data staging earlier, and do rescheduling periodically to handle the dynamic capacity situation. So if there is no historical knowledge, users can employ locality-aware scheduling or capacity-aware scheduling algorithm. Due to the time limitation, I will not dive into details of this algorithm. The major difference between them is the scheduling type. Capacity is a kind of offline scheduling, and the locality is real-time one. We have done an experiment about the latency. The latency of UniFaaS is completely acceptable, and all the algorithms have a modest overhead. We also done a scalability experiment. From this figure, we can see that UniFaaS can have a near ideal scaling performance when it processes 5-second stress task. And this kind of scaling performance is already sufficient to cope with our scenario. We also execute a real-world workflow to test our scheduling performance. We can see that the DHA has the best performance and the highest worker utilization. It can improve the performance of the workflow by 23% when employing an additional 20% of distributed resources. This is compared to using one single cluster. So any questions?
Okay, thank you. Any questions? Great. Any questions on Zoom? Looks like the answer is no. Okay, thank you very much for, I guess, joining us at a hopefully not too awkward time.